You know that feeling when a bug in your code turns out to be an accidental feature? Well, that's exactly what we're diving into today. We're looking at a brilliant new framework called QeRL that found a way to teach massive language models how to reason, all by turning a classic flaw into an unexpected superpower. All right, here's how we're going to break it down. First, we'll tackle why teaching an AI to reason is just so incredibly expensive. Then, we'll look at a popular efficiency hack called quantization and a pretty big problem that came with it. After that, we'll meet our hero, QeRL, uncover its secret weapon, and finally, check out the absolutely game-changing results. So, first things first, let's really frame the core challenge here. Why is it so ridiculously hard and so expensive to get an AI to actually think?
I mean, that's the big question, isn't it? One of the go-to methods is something called reinforcement learning, or RL. The best way to think about it is that you're not just feeding the AI answers, you're letting it explore, try things out, and learn from trial and error. It's super powerful, but it comes with some serious baggage.
And when I say baggage, I mean it. RL needs an insane amount of GPU memory, and that rollout phase, that's where the AI is actually trying to generate its chain of thought. It can take forever. On top of that, it needs a ton of examples to learn anything. Now imagine doing that with today's gigantic language models. Yeah, the whole thing just becomes a massive bottleneck.
So, with RL being such a resource hog, researchers naturally turn to a well-known trick to make things a little more manageable. Let's talk about this popular efficiency hack, quantization.
Okay, so quantization is just a fancy word for compression. It takes all the super precise numbers that make up a model's brain, its weights, and kind of dumbs them down a little, reduces their precision. It's like taking a giant, high-resolution photo and saving it as a much smaller JPEG. You lose a little bit of detail, but it's way smaller and faster to work with.
And the scale of this simplification is just wild. A standard model might use 32-bit numbers, which can represent over 4 billion different values. When you quantize that down to an 8-bit number, you're suddenly working with just 256. That is a massive, massive reduction in complexity. And here's the classic trade-off. You can see it right here. You shrink the model size way down, you get a huge boost in speed, and what's the cost? Usually just a tiny, almost unnoticeable dip in accuracy. For most things, that's a fantastic deal. But, and you knew there was a but coming, this is where our story takes a really interesting turn. This simple, elegant solution, it ran into a huge problem with reinforcement learning. It seems like a total no-brainer, doesn't it? If RL is slow and needs too much memory, you just quantize it, and poof, problem solved. It should be the perfect fix.
Yeah, not so fast. It turns out that one of the most popular methods out there, called LoRA, actually makes things worse. It was super inefficient for that critical rollout phase we keep talking about. The part of the process that was already the biggest bottleneck got even slower.
And we're not talking a little bit slower. The performance hit was huge. It made that rollout phase 1.5 to 2 times slower. So just to be clear, the efficiency hack was making the whole thing less efficient. Insane, right? This is the moment our new hero enters the scene, a framework built from the ground up to solve this exact paradox, QeRL. QeRL, which stands for Quantization-Enhanced Reinforcement Learning, is a totally new approach. The researchers behind it didn't just try to slap an old trick on a new problem. No, they completely rethought how quantization and reinforcement learning should work together.
So let's look under the hood. QeRL has this kind of 3-part secret sauce. First, it uses a much faster type of quantization. Second, it uses a super efficient tuning method. But it's that third step where the real magic happens. It introduces something called adaptive quantization noise. And that's the key to everything.
And that brings us to the core insight, the big aha moment that makes this whole thing so clever and so powerful. So the secret is right here in this quote from the research paper. You know those tiny errors, that little bit of noise that quantization creates? The thing everyone thought was a necessary evil? Well, it turns out that noise actually helps the AI. It forces the model to be a little less sure of itself, which makes it explore more options and find better ways of solving problems. This is a total paradigm shift. Think about it. In normal training, noise is just an error. It's something you want to get rid of. But in reinforcement learning, that very same noise becomes a tool for exploration. It stops the model from getting lazy and just picking the first decent answer it finds. It forces it to be creative,
which is absolutely crucial for learning how to reason. And QeRL is so smart because it doesn't just hope this noise helps, it actively controls it. With its adaptive quantization noise, it basically has a dial. It can turn up the noise early on to encourage the model to explore, and then dial it back later to perfect the best solution it found. They literally turned a bug into a precision instrument.
Okay, so it's a really clever idea, but does it actually work? Let's get to the results, because they are seriously impressive.
First off, speed. Remember how the old method actually slowed things down? QeRL blows that away. It delivers more than a 1.5 times speed up in that critical rollout phase, even faster than the original, unquantized model. It completely flipped the script.
And this is a true game changer. For the first time ever, it's possible to train a massive 32 billion parameter model using reinforcement learning on just a single H100 GPU. This is huge. It opens the door for so many more labs and researchers to work on cutting-edge AI.
This chart just says it all. On the left, you've got the standard method, LoRA. In the middle, there's the flawed fix, QLoRa, which you can see is actually slower. And then way over on the right, soaring above them both, is QRoll. It's not just more memory efficient, it is just flat out faster than everything. So we end on this thought. The story of QeRL is a perfect example of looking at something everyone considered a flaw, a simple error, and seeing its hidden potential. It makes you wonder, doesn't it? What other so-called bugs in our AI systems are just sitting there, waiting to be turned into the next big breakthrough?